This video clip is to show you how to find X and Y intercepts. You can probably already get Y-intercepts, so probably the only part that will be new is X-intercepts. Back to Y-intercepts, if we had the equation y equals 3x plus 5, if I asked you to find the Y-intercept, you could say, well, that is 5. So start at 5, go up 3 over 1, and you say, well, the Y-intercept is 5. What is the value of X there? The value of X is 0. On the Y-axis, the value of X is 0. So I just completely ignore the 3x and look at the 5. 3 times 0 is 0, so y equals 5 when x equals 0. Well, knowing that that's the case, let's do this one. Let's get the y all by itself. Let's add 3 to get the y-intercept. Y equals 3. So the y-intercept in that case is 3. The location of where that crosses the y-axis, we go over 0 and up 3. So what does a y-intercept and an x-intercept mean? If I'm paying back a loan of $100 at a rate of $20 per week, an equation could be written as the loan L equals 100 minus 20W, $20 for every week. So if we were to graph that equation, it would start out at $100 and it would go down $20 every week. And so in this case, this could be referred to as the x-axis. It's really, we're going to be talking about weeks, and we're going to be talking about the loan, but the y-intercept in that case could be the amount we had to start with. So that's kind of like a starting point. And the x-intercept tells us how long to pay off, how long till our loan is paid off. So depending on what the graph, what the equation represents, that would tell us, what we could figure out what the x-intercepts mean and what the y-intercepts mean. But they do have meaning. But in general, we could use x and y, we could use any equation. So if the value of y, or the y-intercept, x is 0, how about the x-intercept? That's where we cross the x-axis. Well, where we cross the x-axis, that means the value of y is 0. So if y is 0, let's just ignore that and solve for x. What value of x would make that true? 2 times that number equals 12. That number has to be 6. 2 times 6 is 12. So it's going to cross the x-axis at 6. So it probably looks something like that. But anyways, so on the x-axis we would go over 6, up 0. We sometimes say the x-intercept is 6, but as a coordinate point that would be 6, 0. About 3y. Okay, so let's graph that thing the way we used to. If we subtract 2x from each side, divide by 3, that would tell us that y equals 4 minus 2/3 x. So that means that we start out at 4, 1, 2, 3, 4, go down 2 over 3, down 2 over 3, crosses the x-axis at 6, 0. So we could just graph those and see where they cross the x-axis to get the x-intercepts. Because when you solve for y, you can get the y-intercept fairly easy, and then you just go at that slope until you cross the x-intercept, cross the x-axis. But we can do it mathematically as well. So if we wanted to find both the x and the y-intercepts, For the y-intercept, x is 0. So 4y equals 12, y equals 3. Well, for the x-intercept, we're going to say, let's write that equation again. But y is 0. So then we say, well, what negative 3 times what plus 12 would equal 0? Negative 3 times 4 plus 12 equals 0. That would work. How could you solve for that? Well, you could subtract 12 from each side. 0 minus 12 is negative 12. Then you could divide by negative 3. So x equals 4. Well, we could see if that would work graphically. We could divide by 4. So y equals negative 3/4 x plus 3. So let's start at 3 on the y-axis. If each of these is 1. Whoops. Okay, so we'll start out at 3 and go down 3 over 4. So we can see the y-intercept is 0, 3. The x-intercept is 4, 0. (5x plus 3y equals 15). X and y intercepts. Well, for the x-intercept, y is 0. So 5x equals 15, so x equals 3. For the y-intercept, x is 0, so 3y equals 15. Just ignore the 5x. Divided by 5, y equals 3. Well, sorry, made a mistake there. It's not going to be the same. If I'm divided by 3, that says y equals 5. So for an x-intercept, that would be over 3 up 0. For a y-intercept, that would be over 0 up 5. All right, that's good enough.